All right, in this video we're going to be looking at the results or the solutions to this quiz over 3.1, 3.2, 3.4, and 3.5. So remember, the order that your questions are going to be in are going to be different from the order that mine are in. So just keep that in mind. All right, so it says, for this one, it says, consider the function y f of x equals 1 over x minus 4 plus 3. What would the equations be for the asymptotes? Well, the vertical asymptote would be at x equals something, and that we get, remember, from the denominator of this this fraction here, the x minus 4. There's a couple ways you could look at this. So one is that we could set this equal to 0 and solve this x minus 4, and we would get x equals 4. The other way to do this would be to think of it this way, and we understand that this graph, the horizontal asymptote and the vertical asymptote are going to move. The x minus 4 means that the graph is going to move to the right 4 units. And so that's where our vertical asymptote would be. And so that's going to be at x equals 4. And the other one, y plus 3, means the graph is going to move up 3 units. So we would have a horizontal asymptote at y equals 3. So we could think about it visually or algebraically. So again, with algebraically, we would set x minus 4 equal to 0 because we can't divide by 0. And so when you do that, you get x equals 4. And since this fraction will never equal 0, 0 plus 3 is 3, so y would never equal 3. So those are where your two asymptotes would be. All right, so for this one, we got to figure out whether or not this function is an even, odd function, neither even nor odd, or both an even and odd function. Now, I'll tell you just this one thing here. It'll never be both even and odd. It's either going to be one or the other or neither. So to figure that out, that's where we're going to have to use this little property, where we're going to replace x with negative x. And if after simplifying, if we put negative x in here, and if after simplifying the function remains the same from what it was originally, then we would say it's an even function. If both terms change to be completely opposite what they were originally, then we would say it's an odd function. But if one changes and the other stay the same, then it's neither. So negative x, when you square it, that would be a positive x squared. So we'd end up with negative 8x squared plus 5. And if you hear a bunch of banging in the background, it's because my wife is making dinner and she is cutting up a bunch of vegetables, so it's in the ceiling above me, it's rather loud. Anyhow, so we end up with negative 8x squared plus 5, which is the same as what we had originally, so that tells me it's an even function. All right, so this is asking us which of the following would represent the equation y equals absolute value of x after a scale change stretching it 3 times the size horizontally and shrinking it vertically to be half the size. So to figure out which one of these, let's do this. Let's start with the fact that it's going to be stretched to be 3 times the size horizontally. And for what that's going to be, remember, whatever happens horizontally, that's going to be affected by the x-axis. Okay, so I'm going to look at these. Now remember, with whatever's happening to the x, the way that we put it in our equation, it's going to be the opposite of what's actually happening. So if it's going to be stretched to be 3 times the size, it's either going to be this first one, x divided by 3, or this third one, in my case, x divided by 3, because that means that the graph is going to be stretched horizontally to be 3 times the size. The impact of 3 times x would actually cause the graph to shrink horizontally. Okay, and that's not what's happening. So it's going to be one of these two. So either the first one or the third one. So let's read on. It's going to be shrunk vertically to be half the size. So that means that after we do something with the x, that's how it's going to be affected vertically. And so the fact that it's going to be half the size vertically, that tells me it's going to be this one here, because this is this is going to happen. The 1/2 is going to happen after we take x divided by 3. All right, here we have a translation. These are a little bit easier. So it says, give the equation of the graph that has been translated 6 units to the right and 4 units up. So if it's going to be, remember to include any negatives if necessary. Remember, if it moves to the right, that means it's going to be in the negative, or it's going to be x plus a negative 6. Okay, because it's going to go 6 units to the right. Because remember, if this had been x minus 6, that means it would move to the right 6 units. If it had just been x plus 6, that would actually move it to the left 6 units. So whatever happens to the x, we do the opposite. Now vertically, it's going to stay the same. So it's going to go 4 units up, so it'll just be a positive 4. All right, so this is another one where we got to figure out whether it's odd, even, or neither. Remember, this last one is never going to get used. It's never going to be both. So I'm going to replace x with a negative x. So we would have negative x to the 5th power minus a negative x cubed. And negative x to the 5th power, that's going to result in a negative answer. So we'd have negative x to the 5th. Negative x to the 3rd power is also going to result in a negative, but a negative times a negative would be a positive. So this would be plus x cubed. So if we compare this to the original function, we had an x to the 5th, now I have a negative x to the 5th. I had a minus x cubed, now I have a positive x cubed. So since both of these changed, this is an odd function. All right, so we want to give the values of a and b for the equation y equals x plus a, or the square root of x plus a. This plus b is happening after we take the square root that would give the graph shown below. If the value is supposed to be negative, make sure to include a negative with your answer. All right, so the original square root function would have a starting point here at 0 and would go up and to the right. So that has been moved 3 units to the right. So the fact that it's been to the right, again, it's going to be a minus 3, because x minus 3 would move it to the right 3 units. Plus b means it's going to move up. It's going to move up 2 units. So this would be a positive 2. All right, here's another one of these. We've got to figure out whether it's even, odd, or neither, because again, this last one is never going to get used. It's never going to be both odd nor even. So I'm going to replace x. Let me just do this. I'm going to replace x with a negative x again. And so we would have the negative x being cubed minus 8. And then that negative x is going to get squared. So negative x, when you cube that, that's going to become negative. So it'll be negative x cubed. Negative x, when you square it, would become positive. So this will be minus 8x squared. So if we notice, the x cubed changed to be a negative x cubed. The negative 8x squared or minus 8x squared stayed the same. So this one, since one changed and the other stayed the same, this is neither. It's not going to be both. It's never both. All right, describe the scale change for the graph of y equals 5 times the square root of x over 2 when compared to its parent function, y equals square root of x. Make sure to read through all the choices carefully. The graph would be, okay, it's not going to be translated. This is a scale change, so it's not going to be one of these first two options. Okay, so it's either going to be stretched horizontally or shrunk horizontally. Okay, so how do we figure that out? Well, we get that from the x. So since it's x divided by 2, that means it's going to be to the opposite. Instead of being divided by 2 to be half the size, it's going to be the opposite. So it's going to be stretched horizontally to be twice the size. And this 5, then, what that means is that's going to tell us how the graph is going to be affected vertically. And so, again, it's not translated. Okay, that's would be if we have plus or minus, so it's not a translation. And it's not going to be shrunk vertically to be 1/5 the size. It's going to be stretched vertically to be 5 times the size. All right, so this one again, we're going to replace a and b with values. It says, what would be the equation for an inverse square function that has asymptotes at x equals negative 4 and y equals 1? So if you want a visual here to help you out, if we have a vertical asymptote at x equals negative 4, and if we have a horizontal asymptote at y equals 1, we want to figure out what would move the graph to have those asymptotes. Okay, so if we're going to move it horizontally to the left 4 units, that means that a would be plus 4. I don't even need the plus in there. We just have x plus 4. So x plus 4 would move it to the left 4 units. And we move that up 1 unit, so we would have 1. Another way to check this is if you use those values, if I had x plus 4, that means that we would not have a value at x equals negative 4, which would be where our asymptote would be. And then if I had plus b, if I had plus 1, well, that means that if this fraction's never going to be 0, we would never have 0 plus 1. So then we would get our horizontal asymptote at y equals 1. So you can always check your work and work your way backwards and make sure that we get the original pieces from our question there. All right, so this one we're just matching the shapes of the graphs based again on the parent function, not the actual graph that's used here, with the parent function that we'd have here. So this one here, let's start with this one. This is an exponential function. Okay, so that one, I'm going to drop in that spot. And then, again, some of these aren't going to be used. Let me just find some of these. Inverse variation. Inverse variation would be one like this one. This is an inverse, not an inverse squared. The reason why I know this is an inverse variation is it's got branches in the opposite quadrants here. So I'm going to drag that one up here. So it's going to be inverse variation. Our inverse squared then would be the ones that would be in quadrants right next to each other, adjacent to each other. So this is going to be an inverse square. And our square root function, we've seen that already, that's going to be this one. So you want to make sure that you have this as your inverse variation. Again, the inverse variation, the way that we can tell the difference between these two is inverse variation is in opposite quadrants, where inverse square are in adjacent quadrants. And this looks like your square root, and this is an exponential. Lastly, with this one, it says, which of the following represents the equation y equals x squared under the transformation? This is saying that we have a scale change, where x is, so this is a rule for a scale change, where we have x divided by 4 and 6 times y. So this means that the graph is going to be 1/4 the size horizontally and 6 times the size vertically. So even just sticking with the vertical part, I know that it's got to be either one of these two middle ones. Okay, because remember, vertically, that value is going to stay the same, that we read that exactly as it is. But with the x's, we do the opposite. So this rule is telling us that it's going to be 1/4 the size. Remember, the rule tells you exactly what's going to happen. So this is going to be 1/4 the size. And so the opposite of that in our equation would be to have 4 times x. So that tells me that this one here, 6 times 4x quantity squared, would result in a graph being 1/4 the size horizontally and 6 times the size vertically, when compared to what the equation y equals x squared. So that would be how we do that final problem. So hopefully that answers the questions that you had from this quiz. If you do have any other questions in addition to what I just talked about or need any more clarification, please make sure to meet with me during my office hours.